Hi, my name is Walenciak, and I'm on a team with Waite, and our project is maritime wind speed prediction using Buoy LIDAR data. Our goal is to forecast wind speed at a theoretical wind turbine 10 minutes ahead using historical wind and meteorological data. The U.S. energy grid requires a constant balance between generation and load, and because of the variability in wind production, it makes it difficult to integrate into the system. Also, constant starting and stopping of turbines puts a lot of wear and tear on conventional plants. So we're using the Buoy LIDAR data from the Pacific Northwest National Labs, and it collects comprehensive meteorological and oceanographic data. It's using LIDAR, and LIDAR stands for light detection and ranging. Here we have an animation showing the Buoy LIDAR, as well as overlaying some of our time series data. This shows a realization of our data set from April 20th, 2016 at 1 minute intervals. And here we have the red bar that shows the mean of the data set. And when we look at it, we do see some evidence of wandering in the realization. These are all the realizations from April 1st to April 20th plotted all together, and they're also at 1 minute intervals. When evaluating stationarity, we do see a constant mean and a constant variance, so we feel like condition 1 and condition 2 appear to be met. Condition 3 appears to be met when looking at the ACF plots because the first and second half ACF plots look the same. However, we do see that these are really slowly damping ACFs, and so that could be a potential issue going forward. If we do assume stationarity, these were two potential models that we have, an ARMA 1.2 and an ARMA 3.1. And for the ARMA 3.1, we have a forecast here that looks to be doing reasonably well. The ASE is fairly low. We decided to difference the data and re-estimate, and we get several models. It does look like this ACF is indicating MA behavior, and we do have 0.2 in both the AIC and BIC. However, we know that doesn't describe the real world, so we decided to go with a 2.1 and then ultimately land on this model right here. Looking at the residuals, they do pass the Young box test, but K equals 48 is not overwhelming. P-value at 0.067. And we do see some issues when looking at the ACF, which could be something we're not picking up. However, we did overfit the model and didn't see any evidence of seasonality. The ACE is approximately same with the non-stationary model, but the utility is unclear and we'll still need to do more exploration. We generated some data with our model, and it does look similar to our original realization. Future analysis include applying another filter, looking at neural networks, and adding explanatory variables.